Almost 10 years before the space shuttle first launched, and 25 years before the first pieces of the International Space Station were connected, NASA launched Skylab, a home above our home planet.
Hello and welcome. I'm John Coward. NASA has long focused on finding out how astronauts can live and work in space. Finding the answer to that was one of the many reasons behind building the International Space Station. But it was also the driving question meant to be solved by America's first space station, an orbital workshop called Skylab. By the time the last crew left in February 1974, astronauts spent more time in space than all of NASA's previous missions combined. Their research would set the stage for today's successes on board the International Space Station. NASA and the United States had not yet landed on the moon when the idea of a space station started taking shape.
Our objective was, in the first place, to get a lot of medical information so that we could have enough data to allow the space station to have crews that could stay up there for 6 months.
The result was Skylab, a workplace in space designed to host scientific discovery without forgetting the comforts of life on Earth. The workshop was built into an empty third stage from a Saturn V moon rocket. A pair of solar wings would fold out to provide electricity for the life support and research equipment inside. The three-man crew would arrive in an Apollo capsule launched aboard another rocket. A telescope to study the sun and other instruments were mounted atop the workshop, and they were powered by 4 separate solar arrays that gave Skylab a windmill appearance. The finished complex was folded up, fit into a nose cone on top of a Saturn V rocket, and launched into orbit from Kennedy Space Center in Florida on May 14, 1973. But the ascent soon grew too rough for the space station, and the air rushing over the outside of the Saturn V tore off one of the large solar panels and a crucial heat shield meant to protect the workshop. The second large solar panel was stuck in place, and Skylab reached orbit critically low on electricity. Engineers struggled to find a fix for the outpost, and it fell to the first Skylab crew to make it work.
The situation that faced our crew as we launched, of course, was the broke Skylab. It was hot. It lacked electrical power. The whole program might be lost, and we launched with a command module full of instruments, many of which we had never seen before. They handed us the checklist kind of on the way in and said, "Good luck, guys."
Moonwalker Pete Conrad and astronauts Joe Kerwin and Paul White lifted off May 25th with a kit to save the mission.
The clock is running, and Skylab has cleared the tower.
The astronauts found the crippled Skylab as they expected and quickly deployed a sun shield over the exposed section of the laboratory.
But when we lost that heat shield, we proved that man was a very, very vital part of space exploration, and that he could do a lot of repairs and fixes.
Repairs and improvements would follow throughout the Skylab program, including spacewalks that ultimately freed that stuck solar panel. With Skylab back in shape, 3 crews of astronauts would go on to prove they could handle weeks at a time in microgravity with few ill effects. They recorded brilliant images of the sun and took the first pictures of solar flares. And they turned sensitive instruments toward Earth, offering the first comprehensive studies of our home planet. Skylab was a pioneering home for astronauts in several ways. Astronauts set a record for spacewalks as they repaired the space station on the first flight, and then serviced Skylab's instruments throughout the missions. They also spent many hours simply learning how to live comfortably in space. So NASA designed Skylab to include many of the features of a home. Take a look. For the first time, astronauts were in orbit long enough to see their hair grow appreciably during a mission. So they learned barber skills that worked in space, notably using a vacuum to get the loose hairs. A vacuum came in handy again as the crews used one to pull water away in the shower designed to work in weightlessness. They adjusted to sleeping in an open space while floating, and they learned the value of exercise, an important lesson that is applied vigorously to the International Space Station crews. Of course, there were plenty of experiments, too. The Skylab medical experiments were perhaps one of the most important things NASA accomplished during Skylab missions. One of Kerwin's jobs was drawing blood from his Skylab 2 commander, Pete Conrad, and crewmate Paul Weitz.
His one weakness that I ever detected on the ground was he does not like needles and has a tendency to pass out when you stick him with a needle. You can't pass out in zero-G. You just can't. The blood does not rush to your feet, you know.
The crews learned it took the body about 16 days to completely adapt to weightlessness.
It was a beautiful machine. It was clean. It was quiet. We had plenty of volume to do our thing. We'd go off after breakfast in the morning. Somebody would go to do Earth resources. Somebody would go do solar physics. Somebody would be downstairs doing housekeeping, and you couldn't even hear or see each other. You'd have to talk on the intercom.
Okay, Skylab, later on in the mission, although I love the mission, a lot of the days were repetitive, and you had to have good self-discipline to really do well. And I felt it took a lot more self-discipline to fly a good Skylab mission than it did to fly a good lunar mission because of this one psychological thing.
The work on Skylab gave NASA fundamental information that would later be used to design and build the International Space Station. Living and working in space brought about completely unexpected challenges and solutions. Even something as simple as moving around inside the large orbiting workshop was not done the way the astronauts expected.
Tell you one thing, the four Conrad boys would sure have a blast up here along with every other kid in the United States if they could ever get inside. It'd beat Disneyland and everything else.
But mostly we said, no, you'll probably just crawl along or move along. And after the very first day of watching, you heard nobody crawl anywhere. Everybody flew everywhere.
There were other, more complex problems to solve too, and the solutions would become an encyclopedia for the International Space Station.
But so many things were learned on Skylab that are going to be needed in Space Station. There's no way to figure them out on the ground.
Before the astronauts learned how to live and work inside the International Space Station, designers pored over the lessons of Skylab. They considered the kind of accommodations astronauts would want, judging them against what worked 35 years earlier. Skylab also contributed to parts of the Space Shuttle program, notably the jetpack called the Manned Maneuvering Unit used by spacewalkers to float free of the shuttle to retrieve satellites. Skylab astronauts flew the prototype jetpack in the expansive workshop area. They proved they could keep control in weightlessness and refined what kind of control system would be used. About 10 years after the last Skylab crew left space, Bruce McCandless used the Manned Maneuvering Unit to fly far from the Space Shuttle Challenger and back safely. The jetpacks would be used again on later flights to catch satellites and bring them back to the shuttle so they could be repaired and returned to service. From what it set out to do to what it ultimately accomplished, Skylab has remained a fascinating element of NASA's history and an important map for its future. One day, astronauts may fly inside vehicles inspired by Skylab and its crews for months on end as they traverse the millions of miles on the way to Mars. For future missions, astronauts will likely be called on to improvise repairs and make other changes to their spacecraft by conducting unplanned spacewalks, just as Skylab's crews proved could be done. For NASA, I'm John Cowart. Thank you for joining us.